Okay, guys, here comes part B. We're going to look at the ones that have a phase shift in them, but it's still the same type of concept. It's asymptote, asymptote, 1, 2, 3. So we just have to find where the two asymptotes are, and we're going to be good to go. And remember, for a tangent graph, since this one is a tangent, we have bx, so 2x equals negative pi over 2, and then bx equals regular pi over 2, and I would just multiply both sides by 1/2, multiply both sides by 1/2, and I'd get my two asymptotes. One of them is going to be at negative pi fourths, the other one is going to be at regular pi fourths. However, here's where I'm going to have a little bit of a different situation. I have my phase shift in between. And my phase shift, I'm going to move it over. And let's do a little bit of combining of stuff. So negative pi quarters take away pi halves. Well, that would be a negative 3 pi fourths. That would be my first asymptote. Then my other asymptote, well, that would be at pi quarters take away pi halves would be a negative pi fourths. So those are my two asymptotes. I'm going to have an asymptote. That's my starting asymptote. This is going to be my stopping asymptote. That will give me one period, right? Now, and just remember, the increments for a tangent graph slightly different. You take the width between the two asymptotes, and you would multiply that by 1/4 to get your increments. So the distance between my two asymptotes happens to be pi over 2. That is the distance between those two locations. So I'd multiply by 1/4, and I would get, I'm going to count off by eighths, by pi eighths. So one of the strategies we use, remember, is common denominators. So if I wanted to, I could say my first asymptote is at negative 6 pi eighths, and then my stopping asymptote would be at negative 2 pi eighths. So when I count off my increments, I could just be technically just counting. So let's see what that looks like. Let's get one little part of this graph done, because in this section they're going to ask you for two periods of the graph. So me personally, I like to get one period drawn and then I just extend it. So here we go. I'm going to go, there's my y, here's my x. Oh, it didn't straighten out. Okay, whatever. And this guy has not been shifted upward. I don't have a vertical shift, but I do have a stretch. Remember, when it comes to these type of graphs, we don't really call it an amplitude as much as it is a stretch, because it doesn't mean it's going to go as high as 2 as low as 2. No, it just means I'm going to take from 0 here, I'm going to go stretch it out 2 units, stretch it out 2 units in the negative direction. But here we go. I've got to count everything off in eighth units. So I'm going to just count backwards. That's negative pi eighths. That's negative 2 pi eighths. That's where I would be. So negative 3 pi eighths, negative 4, negative 5, negative 6 pi eighths. That's where I'm going to start. Now, what did I do? I just mentally counted this out. I'm going this direction because, well, I have negative 6 pi eighths, negative, here, I just put that in my way. I'm going to get rid of that arrow. But what I'm trying to do is just say, you know what? You can always count it out and then go back and reduce all of your numbers that need reducing. And I'm just trying to save a little room here, so I made my period kind of skinny here. But negative 6 pi eighths, I'm going to reduce it. I'm going to call that thing negative 3 pi fourths. And then I'm running out of room, so I'm going to sneak one of these up here. I'll go, that's negative 5 pi eighths. Then I'll go negative 4 pi eighths. No, I'll just call that negative pi halves because I'm reducing it. Then I'd have negative 3 pi eighths. And then negative 2 pi eighths, I'm going to call that thing negative pi quarters. Now remember, that is asymptote, asymptote, and there's my 1, 2, 3 in the middle. Remember, asymptotes on either side, then 1, 2, 3 in the middle. Asymptote, asymptote, 1, 2, 3. So let's mark this thing off. I'm going to use a red color. And this is a tangent graph. It has not been flipped, but it has been stretched. So it starts in the middle there. Then I'm going to go up 2 units. I'm going to go down 2 units. And here we go. I'm going to gradually twist through the middle of those two. And that would be one entire period of this tangent graph. Now, I'm just going to quickly knock out the other one. So remember, I left off here at negative pi eighths. Then that would be 0. Then this one would be regular pi eighths. Then this last one would be 2 pi eighths. But 2 pi eighths, I would just call that pi over 4. But I'm going to stop because what do I notice? I have an asymptote. Hang on, let me get my blue. I have this asymptote, right? Asymptote, asymptote, 1, 2, 3. So I want to make sure, I guess I could have stretched this out a little better, but I did not. There we go. Let's draw that second period of this function. The second period of this function. Now, I've got 2 periods of this graph. And it has been shifted. So let's just go back through this one more time. Remember, a tangent graph, it's not 2 pi divided by b like a sine or a cosine. No, no, no. We do bx equals negative pi halves, and we do bx equals regular pi halves. So that was this stuff right here. It gave me my first asymptote and my second asymptote, but this time we had a phase shift. And when I find out where my 2 asymptotes are, I can find out how far it is apart between them. And that's the part I'm going to multiply by 1/4, that magic number, 1/4. We still use it. So I would do pi halves is how wide my period is, times 1/4, pi eighths. Then I just did this to make my counting easier. I used common denominator trick. And down below, this was me just sketching it out with my common denominators, but when I actually drew the graph, up here, that's when I reduced all my fractions as I went. Could I have spaced this out a little better? Yeah, probably, but it wasn't horrible. So anyway, guys, on this section, they're going to ask us for 2 periods of every graph. Here's the thing. I sketched mine out this time by hand because I didn't like the way the answer key in the book keeps leaving out information and having you guys fill it in. So I got to tell you, I did every single problem by hand. I'll show you the answer key after I get through my next example. So here we go. Let's take a look at my next example. And remember, I'm just bringing in the concept of phase shifting here. And this time, well, got a vertical shift. I'm going to drop this one down. I'm also going to stretch this graph. Yeah, I am. But right here, this is just a 1. So that's going to... for my cotangent, remember we don't do bx equals negative pi halves. We don't do it like tangent. It's bx, so in this case 1x equals 0 and 1x equal pi. That's how we do it for cotangent. So we're going to throw 0 as one of my asymptotes. Then we're going to have x minus pi fourths up to this one. So asymptote, asymptote, 1, 2, 3. Let's find out where those asymptotes are. And I'm going to end up starting at pi fourths. That's my first asymptote. I'm going to end up finishing off at 5 pi fourths. But you can see that it's pi distance between those two. It is. It's going to be pi is my period times 1/4. So I lucked out this time. Pi fourths, that's my incremental count. So everything's going to just be in harmony here because I already have common denominators. And I can make this sketch for this graph here. Let's get an x, let's get a y. And everything's going to be on the right-hand side of this graph. And once again, since everything's already got common denominators to it, I'm going to just count. If this was 0, I'm going to count over. That'd be pi over 4. That'd be 2 pi over 4. That'd be 3 pi over 4. 4 pi over 4. 5 pi over 4. And I'm just going to stop and look at that for a second because that's going to be my asymptote, asymptote, 1, 2, 3. So if I want to just get one perfect sketch, one period, I can always go back and then do the next one. It's always easiest because if you're going to make mistakes, then you get all your mistakes made all at the same time. So once again, just to make it kind of visual for you, if I did count pi fourths, the next one would be 2 pi fourths, then it would be 3 pi fourths, 4 pi fourths, and then we'd stop at 5 pi fourths here. If it helps you do that, write it down at the bottom and then look at it and say, okay, my first asymptote, and I'm going to keep the same color scheme as last time. My first asymptote was here at pi over 4. My last asymptote, or other asymptote, is at 5 pi fourths. I'm going to just go back in and fill in these blanks now. So pi quarters, then 2 pi fourths. Well, I'm going to call that pi over 2. 3 pi fourths I can't reduce, but 4 pi fourths, I can call that pi. And there's my asymptote, asymptote, 1, 2, 3 in the middle. But before I sketch this graph, remember, I'm going to go down 1 unit. This is going to go down a unit, -1. That's my vertical shift here. And then I've got my stretch. I call this a stretch, not so much an amplifier. And that's going to be 2 units down from there. And it's going to be 2 units up from there. I guess my spacing is a little crummy, but there's a 1. That would be a depth of -3. Let's get some dots on here, but I'm going to do that with red. Keep the same color scheme alive. And remember, this is a cotangent graph, so it will rise on the left and fall on the right. So when I put my middle dot, here's my center dot right here on the center line. I guess I should have marked that center line. I should have. I'll go back and do it later. Here's this guy. Here's this guy. Asymptote, asymptote, 1, 2, 3. And I'm going to gradually cut through right there. And that is 1 period of my function. I'm going to grab my black pen and I'm going to extend this. Also, I'm going to draw in my center line here. I'm going to say, okay, whoop. There we go. That should be my center line. Remember, all the information you provide me on a graph especially is golden, because you might make a little tiny boo-boo. Like I didn't do my spacing perfectly here on the side, on the y-axis. But if I can read everything, I'm a happy guy. I really am. So here we go. Let's do 6 pi fourths, 7 pi fourths, 8 pi fourths, 9 pi fourths, 10 pi fourths. Did I overdo it? Yes, I did. I didn't need to go to 10 pi fourths. I'm going to get rid of that one. How did I know that? Because I say asymptote, asymptote, 1, 2, 3. So there's my first asymptote. my second one, and I should have 3 dashes in between it, and I do. So let's go back. This time I'm going to speed things up though. 6 pi fourths. That would be my next one. I'm just going to reduce it in my head, call it 3 pi halves. 7 pi fourths can't be reduced. But 8 pi fourths, that's just 2 pi. And then this should be the end of the road, 9 pi fourths. All right, so remember, always reduce your fractions. Don't make somebody else come back and do it for you. You are the controller of that information. All right, asymptote, 1, 2, 3. So I got my dot there, and I got my other dot down here. And once again, this curve, went off the charts here. This curve should be congruent to the first one. I mean, they would be identical. I am a human being. I am trying my best to sketch it so that the first curve looks exactly like the second curve, but I'm not going to do it as well as a graphing calculator would. But then again, a graphing calculator is not going to clearly mark all this information for you. That's you. You are the one who controls that. So, I wanted to go through this second video here and give you guys a look at what it looks like when we shift these things phase shift style. So that's my one example there. My other example here for tangent, I did not flip either of these graphs. Remember, when you flip a tangent, it kind of looks like a cotangent, and when you flip a cotangent, it looks like a tangent, but it's where the asymptotes are that makes them different. All right, so here we go. I got a big quick scroll. You're going to see a blur here. Yep. Got a big answer key for you. Hang on. But this right here is page 166 of the trig book. And I want you guys to do the odds. 7 to 31 odd. 7 to 31 odd. However, I did every single one of these. I personally did every single one of these problems. I want you guys, like I said, this is page 166. I want you guys to do the odds, but really, this is our last big hurrah. This is our last graphing thing. So if you are good at this and you get all the odd ones correct, awesome. If not, I included every even one. So if you want to go back and practice the evens that you skipped over, go for it. But here's the answer key. I hand did these on just white paper. So I took photos of it and embedded it in here. Let me scroll down. I'm going to start at the bottom. But if you want, take a picture of it. Oh, and also, by the way, remember, I did not do this to you on the test. We don't have time to mess around. All it is I'm taking the GCF out so I can get my B value. But for problem number 19, use that version of the problem. For number 21, use that version. For number 29, there's the rewritten version. And likewise, if you do want to go back and do the evens for practice, here's all the rewritten versions of those. Okie doke. Let me show you the answer key for all this stuff, and I'm going to do it one at a time. That's the way I did it. Okay, wait, because for some reason when I loaded all these photos in, they went upside down on me. So I have to go back to the bottom of my lesson. Here, sorry. And here is page 166. This is section 4.3. Now, I did 7 to 31 all. I'm telling you guys, remember, I am saying you guys have to turn into me the odds. So here is number 7. These ones, they only ask you for one period of the function. So this is just my handiwork. You're going to see that I had some work on the side or whatever. If I did any work on the side, I left it there. But this is where you're paying attention. I want your graph to match with my graph. All right, so there's number 7. Okay, and if you want, here's number 8. You can pause it, take a picture of it. But You don't have to do the evens, so you might want to pause this one. Take a picture of it, because that is number 9. Here we go, number 10. If you want it, pause it, take a picture of it. Or you could just come back and watch this video again. Here's number 11. And so on and so on. So here's number 12. Oh, and by the way, just remember they use the word stretch and shrink. If you use a fractional value like that, you're actually kind of shrinking the graph down, compressing it down. All right, number 13. Number 14. And then we go number 15. Here's number 16. So if you're like, oh, this takes forever. Look, I did all of them. So I know. Oh well, it takes a while. Math takes practice. Number 17. You don't get good at math by watching somebody else do it. You get good at math by playing around. All right, number 18. Number 19. Now, this is the part where they started asking for 2 periods of the function. So just a reminder, every curve, like this first curve here, this second curve here, technically they should look identical to each other, but I am the worst artist in the world, so try your best. On test day, you know what? You give it your best effort so you can really impress me. But here we go. Number 20. You'll see that I don't have it exactly perfectly congruent. But there's my answers for number 20. There's my work, just in case you want to see that. Number 21. There's number 21. Remember, I had to rewrite it. That's the version you'll see on the test. And then this one, I accidentally graphed it as a tangent and went, duh, it's a cotangent. So the highlighted one is the one I want you to see. So let's say you guys do this on the test. You have all kinds of time in the world to go back and redo it. But I didn't want to redo it. I was like, I did all these. Okay, so here we go. Number 22. This is problem 22. There's my graph. Remember, this is the part you're looking at. That's the part you want. And I can see right here I did not mark my increments, so that's bad. I should have done that. Okay, and away we go. Let's move on down the road. 23. There's some goodness. 24. If you want to check it. And I wrote same as 23 but flipped because it's true. Okay, number 25. And 26. We're almost there, guys. Yep, 26. 27. 28. And then here we go, number 29. I forgot to do this one over 2 periods, so I extended it on the paper here. That's why it looks a little weird. Number 29. Number 30. And that was it. Or 31. Did I do 31? Yeah, I did. Oh, my God, I didn't even do this. Hang on, just in case you do want to check this one, let me embiggen it. Oh, check that out. That was fresh. Okay, so there's number 31, the last question. All right, guys, so remember, you're practicing. I'm in the room. You need help, you come in, ask, because we just bang out all these graphs this week. This is all we're about right now is graphing. Okay, good luck to you. Bye-bye.